RTLS. As I mentioned, he's an aerospace engineering by the University of Brasilia and master in application of space technology by the Beijing Aeronautical and Aerospace University, Beihang University, through the master program created by the UN through the Brazilian Space Agency and the Chinese Space Agency. He is founding member and was director of research and development at Zenith Aerospace, currently based in Shanghai, China. Luan, welcome, and please go ahead with your presentation.
Hi. Hello, everyone. Can you hear me well? Okay.
Yeah.
All right. So first, good morning to who's in China, and good night to everyone over there in Latin America. I would like to thank the opportunity given by the Centro de Innovación and Emprendimiento China and Latam. As Claudia already explained, introduced, my name is Luan Henrique. I'm the co-founder of the startup GeoSpace, Geoespaço, and I will be talking about the benefits of using GEO AI in data processing, which is one of the areas that we have been working on in developing solutions. Okay, here's our short summary. First, I will shortly introduce about the GeoSpace company, our company, and then a little bit about GIS technology, which is a fundamental key to our solutions. Okay, in case some of you are not familiar with, so I will just talk it briefly, and then I will present about the SuperMap platform. That is this GIS platform that we use, and they are our partners. We represent them in Latin America, especially in Brazil. Okay. And then to finish it, I will show some applications that we, application examples that we developed. All right, so GeoSpace was founded by these two guys. One's me, Luan, and Daniel is my partner. Claudia already introduced. We came to China first to do our master degree on Beihang University through this program, sponsored by Chinese Scholarship Council, but created and enrolled by the Center for Space Science and Technology Education in Asia and the Pacific, which is inside the UNIOSA, that is the Office of Outer Space Applications in the United Nations. Okay. So here's our headquarters. We founded in 2018 in Zhongguancun, in Beijing. Zhongguancun is also known as the Silicon Valley area for startups in China. And 1 year later, we opened also our branch in Brazil, is in Brasilia, the capital of Brazil. So a little bit about the GIS technology. To understand better the work we've been doing, we need to understand the fundamentals of the GIS technology, which is our base and is where we deploy our analysis and publish the results where people can visualize. So in other words, it's a geographic information system. Is a system designed to capture, store, manipulate, analyze, manage, and present all types of geographical data. So basically, we use it for this four reasons: for objects, mapping where the things are, mapping quantities, mapping densities, and also find what's nearby. And the SuperMap platform, it was founded on 1997. Nowadays, it's present in more than 100 countries. The SuperMap software the company, it's a leading provider of GIS software platform and services. In 2009, they were listed as the first GIS software company in China. And currently, they occupy the first market share in Asia and the third in the world, according to ARS Advisory. Basically, we have these five pillars of technology. We call it the BIT-CC. And explaining very shortly, we have the cross-platform, which means that you can use our technology and our applications in several terminals. It can be computer, desktop, on Windows, Linux, iOS systems, Android, and you can have the same environments and natively developed in each one of the systems. So we can, that's why we call it cross-platform. And you have the Cloud Edge client, which is our cloud service. Basically is a place that you can program in cloud, and you can publish your services, and your clients or partners in your projects can check online. Doesn't actually need to be on a offline environment to check and to do analysis and contribute to the work. And we have the three main technologies, which is the big data GIS, the artificial intelligence GIS, and the three-dimension GIS. Today, I will be talking specifically about the AI GIS, okay? AI GIS technology. So currently we have some types of approaches to program and artificial intelligence. And the most common that it's widely used and discussed everywhere is the use of deep learning, which is one branch inside of the machine learning. And then we have a lot of theories like convolutional neural network, cyclic neural network. It depends of the application you want to achieve. And we need to talk more also about the conjunction of AI and geo application, geo approach. So here we mentioned some of them, like the GeoDA is a free and open source software tool that serves as an introduction to spatial data analysis. So it is designed to facilitate new insights from data analysis by exploring modeling spatial patterns. And we also have the Geo NLP, natural language processing. It's more used to identification of real addresses. For example, you can use for when you want to locate occurrences such as crimes, or even related to the pandemic that we are living in the entire world, right? In a smart way. So you have a computer analyzing the data from trusted websites, can be like organizations, police departments, and having all this data plotted visually on the location. So you can have a dashboard to better analyze and do any statistical work that you need, or to prevent or to monitor in some situation. And we also have the GeoCV, which is mainly related to 3D projects, but it also can be used for image object recognition. So here I'm going to show some examples, some applications. Here's a classic case of object recognition. Here in this example, it's about airplanes, but it can be used according to your project. If you need to make to calculate number quantities of some objects in the determined area, that's nowadays the best way to do it. Here is another example. That's an interesting one about urban planning, so and maintenance and monitoring, where you can, through deep learning, extract an oblique photogrammetry by the buildings. And as you can see here, the image, everything is geo-referenced. So here the map is kind of 3D, but it is merged with satellite image. So it means that you have like real dimensions, real locations, and it can come from remote sensing data, but also it can come from drones. It can actually, it depends of the size of the area that you want to study. Generally, for large areas, it's better go with remote sensing data. Okay. Here, another one where we can improve the mapping of the roads and streets, determining a place of study. And we can see that we improved a lot the results when we combine this, the convolutional neural network with the geotechnology. Here a short example in 3D applications when you want to detect objects. That can be very useful for agricultural applications or monitoring some species of plants or animals. More complicated because it's moving, but it's also possible. Here a binary classification, extracting building footprint from image when you need to do some statistical analysis on city, urban, the urban parts. We have more examples of it. For example, land use classification from satellite image. As I said, when we want to evaluate large areas, using remote sensing data is the best way to do it. And of course, depends of your requirements. You may need higher resolution and so on. Here another example of a scene classification. So here you can see in the legend, you can easily quantify the area, the amount of area or the density of each zone that you have in the place. Like if it's construction, if it is urban places or plants, water, and etc. And also, of course, the AI can be used not only to process an image, but you can also use it to increase the speeds or increase the speeds of your analysis to decrease the time processing. So where we do the distributed analysis. So here we have, for example, a computer with 24 cores, and it distributed in the same power processing, but in different computers, smaller ones, and you can increase and even in 22 times the speeds of the processing data. And yeah, I would like to get the opportunity to present some other AI applications with GIS, not necessarily related to remote sensing, but still very interesting and very useful technology to be used. Here we can have these 4 pillars like AI attribute collecting, AI survey and mapping, AI cartography, and AI interaction. I'll be not discussing about all of these ones, but I would like to show some examples related to these ones. I think it's very interesting technology. Here an example of data collecting, for example, for illegal parking. You have automated systems where you can scan the plates of the vehicle and you get all the informations, including the location and time that the vehicle was there. So of course, it can be used for other applications like ads posters in illegal places or illegal disposal of trash, manhole covers. So the idea is that you can create a database where you can manage and visualize it easily. And in this case, for urban management cases, it for sure can help like managers, responsible person to better take decisions and visualize the problems that the city has. So when you have all the problem mapping, you can have a database located in the referenced, like you can see here in the graph. And it also can be used for recognition of hand gesture. That's not necessarily a technology that can be used to find things, but more related to how you can visualize data. Here we can have some examples, like you can use your hands to to visualize, or with both hands. It will depend with one hand or both hands. It will depends of the wish of the executor of the problem, the project. Here one more example with whole body recognition. That's a dashboard used for smart cities. I will show a little bit about this kind of applications too. So yeah, we have seen AI working in the benefits of geospatial geo applications for image processing. But we also can see the geospatial visualization helping the AI to achieve better applications, better results. For example, here it's a visualization of traffic flow monitoring. This is in real time. So as you can see here, you may have like cameras, and the cameras can be adapted with AI technology, and you can use it to do your analysis, monitoring what you need. And of course, this example is cameras, but imagine that you can use any kind of dispositive like IoT sensors, or cell phones, anything that you can relate, can collect data, you can use it, and you combine the big data with the GEO AI to do your application, to generate your dashboard. Here another example of using this one is like a violation monitoring based off geofencing. So it's one alternative way to control the traffic, for example. So the applications are endless. You just need to figure out what is your problem and how you can solve it, how you want to solve it, and something can be done. Another example, for example, is cities that has pipeline gas on the city. You could have, for example, sensors in all the pipelines through the city. And if the sensor collects like a drop of pressure or increase of pressure, maybe a leakage, you can easily find where the place happened and the places that is being affected on this leakage, and go exactly in the place to fix the problem. So that's what we called smart cities, when you have a smarter way to solve problems related to the entire city. And concluding, we can apply AI on remote sensing data to have like more accurate data, higher speeds while processing the data, and improve the capabilities on several applications. But when you combine the AI on remote sensing data, but you also combine with our GIS platform, you can easily integrate with different source of data. As I showed you, you can combine, for example, the remote sensing data with video cameras, with drone pictures, with cloud points, and IoT data. You can combine all in one place and have it all together to generate your solution. And of course, you can have more controllability, as you can use different kind of systems, as I said, like Linux or Windows. You have a better data management. You can improve the visualization of data and results. And of course, you have a very big potential of cost saving once you can solve many problems in one system. integrated. So yeah, I wanted to be short. I didn't want to be boring this presentation, but I will be answering the questions if you have time. And if you want to have a discussion about some projects, I'll be glad to answer. You can contact me through these emails, Luana, GeoSpace or Contato. And yeah, I hope we can still discussing about this kind of technology. And thanks again for the Centro de Inovação e Empreendimento for the opportunity to talk with all of you. Thank you so much.
Thank you, Luan. There are a couple of questions. So, okay, let's go with the first one. How much time it takes to do the analysis of the images or in recognized object, or maybe it's made in real time, about the images obtained by satellites, and how much it costs to maintain all the data that you use in your application. Is it expensive?
Okay, yeah, this question I will answer in, it's one question with a lot of questions inside. Let's go per parts. The first one, we have the tool, we don't have the data. So you need to provide the data to our tool to process the work you want to do. Okay, so it's a different thing. This is a tool. Always remember that. And about costs, it depends of the frequency of time you want. For example, if you want to use image from satellite coverage, it depends. If your satellite data is for free, it won't be expensive. But if it is a paid satellite, it will depend of the price of the image. But just to give you an example, for example, there are some satellites that one image can cost around $2,000, $3,000. You have one image. So let's say I want to evaluate every hour. Means that every hour you need one image. So depends how long you will do this project. For example, you have 1 year with every hour paying this much. So generally you don't do real time with remote sensing because it's very expensive. Generally you can usually have, when you have a lot of budget, you can do like a weekly analysis, or when you don't have too much, you can do for monthly, 3 months. So it depends of your budget. Okay, it can be cheap and can be very expensive. When you want to real time, generally you like to use from camera, because you can deploy the camera and it will be there recording. Another thing that was in this question is the time to processing, right? It depends of how developed are your artificial intelligence, how refined it is. How is the process? For example, let's say you want to calculate how many cows is in a cattle production. Okay, so first you have this data and put it in a computer to analyze what is a cow or not, and then it will give you results. But you probably will have some errors that identify it as a cow, or maybe identify something that is not a cow, or maybe miss it some of them. So you can go manually and tell to the computer like, oh, okay, this is a cow. Maybe it is in another position, so the computer could actually know what is or not. And then you put it back, and you can do this process until you have the most refined model. Once you have it, it should be much faster to get your analysis. So you have a time to prepare the solution, and then you can do it much more fastly. Okay. So yeah, I think I answered all of this one.
Yes. There is one more question. I think we can go with one more. If I want to analyze orthomosaic with deep learning, the software includes a cloud support computer for big data.
Sorry, I didn't get the question. Can you repeat, please?
If I want to analyze orthomosaic with deep learning, the software includes cloud support computer with big data.
Yes, actually we have different packages. So if you need the clouds, we can have the clouds. You can create a portal and programming everything in your cloud, and you can design for the participants of the project to have a login to go in to see. Or if you just want to show the results, you can give a link or a QR code, and the person can scan it and visualize what you have done. And concerning about the deep learning, you can use either offline or online. It depends of the how you want to manage.
Okay. Well, I think there's one more question. Maybe you can go with in the chat and you can answer that question directly, Luan.
All right.
Okay, so we finished with your presentation. Now I'm going to switch to Spanish.